Okay, let's go through this together then. N times n is n squared. N times -2 is -2n. 2
Oh,
times n is positive 2n. Positive times -2 is -4. I heard an O. Did you see your mistake or
I
what?
didn't make it a negative. I didn't make 2n a negative.
Yeah, so the sign goes with the number in both cases. Both binomials.
Uh-huh.
And you can see that those two terms are the same. -2n, positive 2n are the same, so they cancel. So that's n squared minus 4.
Yeah.
All right, on to number 2.
Yeah.
Here we go. Graph f of x equals x and f of x equals x plus 1 on the same coordinate grid. Compare the graph of f of x equals x plus 1 to the parent graph. Use the y-intercept in your comparison. All right, first thing here is that when it says f of x equals x, you can really think of this as y equals x. And another way to write this is 1x. There's really a 1 in front of the x plus a 0. Now you might wonder why you would write it this way. You want to identify the slope and the b value. We were doing that yesterday. Having it in this form allows you to quickly do that. The slope is the number in front of x.
So slope is just 1.
Just 1, and the b value is 0. So if we were to graph this one, we start at the origin 0, 0. That's the b of 0. Slope of 1 really means 1 divided by 1. So that's up 1, right 1, up 1, right 1, and so on. Like that.
Uh-huh.
Now we're going to work on the second one. You tell me when I can do that. I don't want to rush through it.
Yeah, we can do that one.
So similarly, it's really y equals x plus 1, and that's really 1x plus 1. You can always put that 1 in front of the variable there. So this means the slope is 1 again, just like before, but the b value is 1 this time. All right, so b of 1, slope of 1 means to go up 1, right 1, up 1, right 1, and so on. You should notice something about these two lines. How would you describe them to someone?
Parallel.
Parallel. So that's what they want you to say. They want you to say parallel lines, or you could say things like same slope, different y-intercept.
Yeah.
Is that clear?
Yeah.
All right. Moving on to number 3. Find the degree of the monomial. So the degree is the sum of the variable exponents.
Uh-huh.
And you'll notice 1 is not written above the x, but there's only a 1 there. So the degree in this case equals 1 plus 2 plus 2.
So the degree is 5.
Yes.
Yeah.
Knowing that formula, knowing it's the sum, that's the shortcut to being able to do a problem like that.
Yeah.
Okay, multiply this. So it's minus 2CD times each of these terms inside here. So there's kind of an intermediate step if you want, where you actually write minus 2CD times minus 4C squared, minus 2CD times D, minus 2CD times 3C.
Uh-huh. All right.
And then you got to multiply here. You multiply the numbers. Minus 2 and minus 4 is 8. C to the 1, C squared is C cubed. D remains the same. Do you want to try the rest?
Yeah.
Let me know if you got any questions as you go through that.
So 8c cubed d plus -2cd squared,
Good.
and -6c squared d.
Yes.
Yeah.
Great. Number 5. Number 5.
Yeah.
5/8 says to simplify, which can mean really means a lot of things. When you have fractions like this, the bottoms need to be the same to add or subtract. When the bottoms are the same, you keep the bottom
Mhm.
and then you subtract the top. So 3x minus 4x.
Negative x.
Yeah, negative x. So negative x over d to the power of 3.
All right. We can go to 6.
Yep. On it. All right, so we've not seen a problem like this. You and I might have done something like the square root of 16 where you break it apart, 2 and 8, 2 and 4, 2 and 2. Because it's a fourth root, you're now looking for 4, like instead of a pair, you're looking for 4s. So in this case, there are 4 2s that you circle.
Mhm.
So you're basically looking for a number that when you multiply by itself 4 times, you get 16. So that's 2.
Yeah. Oh, okay.
I'm happy to give you kind of one like this if needed. I know that was maybe
Sure.
not.
Yeah.
So like a related problem would be like, what's the cube root of 8?
2.
2. Okay. How about the cube root of 27?
Mm,
So 27 breaks apart into 3
8.
and 9, 3 and 3. See how there's 3 3s?
Yeah.
Okay. There's only so many of these that work, full disclosure, like there's not this infinite list that you need to know. There are an infinite number of these, but it's not that many to know. Okay. 7's kind of a loaded question here. If you're ready for us to move on to that.
Yeah.
All right. The first type of factoring that you're always supposed to do is the greatest common factor. And we really want to look at the numerator and denominator separately. Okay. So when you look at just the 3y squared minus 12y, what's the greatest common factor there? What goes into both the 3 and the 12?
Or 3.
3. And then between y squared and y is the smallest exponent. If you divide each of these by 3y, what does that become?
4y. Or just
3
4.
3y squared over 3y is just y minus
4y.
just 4. The y's cancel. Let me clean this up here. Maybe it's not clear.
No, it's clear. It's just.
3y squared minus 12y.
Oh, I just saw it.
Yeah, and
The y is squared, so you still have 1y left.
that's right. That's right. Now we're going to do the same thing on the bottom here. We're going to just look at it. Okay. 9y minus 36. What is the greatest common factor? 9.
9.
9. So what goes in parentheses?
Y and 4.
-4. Good. Okay, now we combine the two things. The top was 3y times y -4. The bottom is 9 times y -4. You can cancel if it's the same thing on the top and the bottom. Is it the same thing?
Yeah,
So the y -4 is
yeah, and Y minus 4.
that cancels. So that leaves you with 3y over 9. When there's the same in the top and the bottom, or a number that goes into both, you can divide and cancel.
Yeah. Well,
So do you see how 3 goes into both 3 and 9?
yeah, but the Y doesn't matter.
Y stays there.
Okay, so Y over 3.
Yes.
All right.
Okay.
Okay.
We can always do one like that. Let's maybe get through, all these before we tackle ones like actually, maybe we could do another one now if you wanted.
All right.
Um,
Let's do one more like that.
yeah. So I'll make this one. Boy, these are not great. So like 7. Let's go 5x squared minus 20 x over 10x minus 40.
Okay. Okay. So 5 on the top, 5x in parentheses, x minus 4.
Good.
And on the bottom, 10 in parentheses, x minus 4.
Okay, good start.
And then you cancel x minus 4,
Okay.
and you get 2, or x over 2.
Yes.
Okay.
All right. So that's one like it. Let's keep going here. Number 8.
Yeah.
Number 8. All right. A over b to the -1 times all this stuff in here, 2a cubed over b to the -2 minus c to the -3b cubed over a. My sort of general recommendation here would be to eliminate or change the negative exponents.
Yeah. So like a b to the first over 1,
Yeah, and you guys put everyone.
and then 2a cubed b squared, and b cubed over a c cubed.
Okay. That's good. Now this one's very similar to one we did earlier. You're going to take that AB and multiply it into both.
Uh-huh.
So the first one I think is much like much similar to the one we just did. Second one, you may want to do it in like 2 steps. You may want to multiply the numerator and then decide if you want to cancel or can cancel.
Mhm. So just give me a second. Yeah. 2 and 4, so we can cancel the A over here.
Yeah, the 2 A's cancel. And you're left with 2a to the 4th b cubed minus 2b to the 4th over c cubed.
Yeah. All right, we're good.
Cool. All right, number 9.
Yeah.
All right. There's a couple of ways to do 9. One way is to try each of the numbers. That's relatively slow, but you could do that. You could do 4 minus 3 and then put the 1 in for x and see if it's true or false. The way that you're probably supposed to do this is to actually solve this for x.
Mhm.
Okay, so I think we should do it that way.
Yeah.
All right, so is the 4 positive or negative?
Positive.
Positive. So your focus is on the side with the variable on the left here, and you want to undo 4 by subtracting 4 from both sides. That minus goes with the 3x, minus 3x greater than or equal to -9. What's the next step? How do you undo this right here? Or what is the -3 doing to the x?
It's greater than, or it's multiplying. Yeah, so
Yes,
you add that
so you
to
undo with division. Now over here off to the side, if you ever multiply or divide by a negative,
positive, or if they're both negative, it's positive.
yeah, but the inequality flips. Inequality flips.
It flips.
Yes. You said that like you've never seen this before. So that's we got to maybe look a
Yeah,
little bit more into this. Is this a recent lesson 50?
yeah, it's pretty recent, but
Okay.
I may have just missed that or something. But
It's kind of the whole point of these problems is you end up flipping the
like,
inequality.
because I have like solved the inequalities, but I haven't really seen the where you flip it.
Okay, so you flip it whenever you multiply or divide by a negative. It's talking about the bottom number. Like it doesn't matter that this number on top is negative. It's only the bottom number that matters.
Because the bottom number is negative, it flips.
Yes, and if you multiply by a number, it flips. That's negative.
Okay.
So the solution set here is saying x is less than or equal to 3, which means that you want to the answers that work are the ones that are less than or equal to 3.
So 3 and 1.
Yes.
Okay.
All right, let me give you at least one more inequality to solve. All right, let's go -8 minus 2x less than -6.
Okay.
Y luego no lo vas a enfocar, lo vas a hacer así, y luego lo vas a hacer así. Y ya que termines, vas a dejar limpios. Lo vas a mojar y lo vas a limpiar.
Okay, so the inequality would be. Oye, oigan, bájale por favor. Bájale por favor, Isa. So x is greater than -1.
Which of these is correct on the right?
-2.
Greater than means it's
Yeah.
to the
So
right.
it's 1 and 2.
Yes. So these two. Good.
Yeah.
I mean, there's actually there's more types of problems like this. Does this look pretty representative though of what you
Yeah.
saw in class? Okay.
We can move on.
All right.
Least common multiple.
Yeah, least common multiple. So if you were to multiply 3 times 8 times 9, that would give you a common multiple, but it might not be the least one.
Mhm.
There's a couple of ways to do this. Some instructors show it this way, where you just start writing the multiples until you get a match. That's kind of slow. There's also a factor ladder that you could build for each number. Does any of those sound familiar to you?
Yeah.
Which one? Just multiply or just putting these out and until you get a match, or building a factor ladder?
Well, building a mat or like putting them all up if it's like a small, if it's like a small number, but
I mean, you can see this isn't going to work real well because it's like going and going and going. The factor ladder is like this: 3 and 1. For 8, it's 2, 2 and 2, and then for 9, it's 3 and 3. So you start with the first 3, and then you look at the next grouping of numbers, and you hope that you've got a match, but you don't. So that means you can multiply by 2 times 2 times 2, and then you've already got 1 3 in your list, so you have to add another 3 to your list. So it ends up being 72.
wait, so you put them all.
You
Like you
Go ahead.
like for each one, you just put all the factors.
Yes, and
Well,
then you collect. You start with 3 because you need a 3 to get that 3, and then let's just say, well, since you don't have any 2s, you got to use all those 2s. But when you get to 9, it's 2 3s. But you already have a 3. That's why you only add one more 3.
oh, okay, yeah.
If you don't like this way, I mean, you can just build the list. It's faster, but you have to know when to add the numbers or not.
Yeah.
And
I mean, and
this
it's a good method. I'm gonna see real quick, like maybe what they want me to do on the book.
Sure.
Finding the least common multiple. Write each number as a product of prime factors. Use every factor of the given number as a factor of the least common multiple. Use each factor the greatest number of times it is as a factor for any number of. or expression. So they kind of get like then each number has a prime factorization. It's basically like,
Yeah, you do a prime factorization of each number and you look for the like overlap.
yeah,
You get where you can, and
yeah, that makes sense.
okay.
So if you want, we can move on to 11.
11. Okay.
And then I'll send you like another picture or something.
Sounds good. There are a couple of ways to solve a system of equations. Did you guys set them equal to each other or do graphing? Do you remember what you might have done?
Well, is this one where you like, or it's,
Since they both have y, you can set them equal. You
yeah,
can set 3x minus 2 equal to x plus 2 and solve for x. So you can subtract x from both sides, add 2 to both sides. 2x equals 4. Divide by 2, so x equals 2.
uh-huh.
But that's only one of the solutions. You have to get both x and y. You can't just give me one of them. That's 50%.
And then
Yeah.
or to find y, you just subtract it.
You go back to one equation or the other. Your choice.
Yeah, we can go back to the,
Yeah. 2 plus 2 is
Yeah.
4. All right. I'm just step away for 30 seconds again. But if you want to send that over, we'll get right on the next assignment. Did you get that sent over? Looks like you did.
Yeah.
Great.
And also maybe we could do one more of the system of equation one.
Yeah, let me make one up here. Absolutely. Sorry, I should have done that before I left. So let's go y equals minus 2x plus 1, y equals x minus 5.
Uh-huh.
Why don't you try that one on your own, please? How are you doing on this one?
So made it like. Oh, I wrote it wrong, I think.
You have to set the equations equal to each other.
Yeah, it's just like put the wrong number, but I did do like 2x plus. Oh my god, this is I was doing the other one.
Yeah, subtract x from both sides, subtract 1 from both sides.
So
Should give you minus 3x equals -6. Divide by -3. X equals 2. And then you can use either equation. They both will give you the same answer.
plug it in. Okay. So you just subtracted what they have in common. Or not they have in common, but
I'm not sure. I guess I'm not sure what you're asking, but you're going to take that 2 and put that back into either equation. Doesn't matter which one.
oh yeah. I'm just looking at the problem.
Okay. There's a couple more of these on the page you just said, 13, 14, and 15.
Okay, so we can work on that.
We can do those, or we can do 12. What would be best?
Oh, which 13, 14, 15? Are you talking
Yeah,
about
13, 14, 15 on the page you just sent their
that
systems,
one?
kind of like we're doing.
We can start on 12.
Okay. All right. G wants to construct a picture frame made of wooden pieces that are 7 centimeters and 3 centimeters in length. He needs 20 pieces, and the total perimeter of the frame needs to be 108 centimeters. If G cuts out 3 centimeter pieces first and is left with 0.8 meters of wood, will he have enough wood to cut the 7 centimeter pieces? Wow. Okay.
20 pieces.
So we're gonna call X the 7 centimeter pieces and Y the 3 centimeter pieces. So we have X plus Y equals 20. Now the perimeter of any sort of rectangle.
It's just all of them added together.
Yeah, but you got to, it's double. It's 2x plus 2y equals 108. But we know the length of these. So it's not 2x. We know that the x piece is 7 and the y piece is 3. So it's really like we should have done this 7x, 7x, 3y, 3y. And those add to 108.
Okay.
I mean, this is fairly complicated. I mean, I don't see anything like this very often.
This,
Uh,
yes.
But it is a system. Like the second one becomes 14x plus 6y equals 108. And we can do a couple of things to solve the system here. Do you remember elimination? Actually, that doesn't, is that going to work?
Sure.
Just trying to look at it. Actually, let me solve this one with another thing. I feel like there's a possibility I made a mistake here in setting this up. Yeah, I did. Okay, let me look at this one more time. Maybe this isn't a system. Is 63 a system? I guess it is. Okay.
63.
Yeah, I'm looking at the number inside parentheses just to see what lesson it's from. It's the same as number 14, which is elimination. So I guess this is okay. He needs 20 pieces. So X is the number of 7, Y. Okay, I see. So the mistake I made here, let me just double check that before I say any more.
1 equals 20.
Okay, now I've got it. So this perimeter is not quite correct the way I've got it here. X is the number of 7 centimeter pieces. Y is the number of 3 centimeter pieces. So we know that
Pieces.
7 times X. Let's just say there were 5 7 centimeter pieces. 7 times 5 would be 35. Y, we know that it's 3 times Y. That has to be the 108.
Uh-huh.
So this is the correct setup here, and maybe we'll just solve it before I talk about that later. So to solve it, we're going to use elimination here. Let's multiply by -3. So that becomes -3x minus 3y equals -60. 4x equals 48. Divide by 4. So x equals 12. To find y, we're going to go back to either equation. I'm going to recommend we use the first one, x plus y equals 20. If x is 12, that means y must be 8.
Yeah. But like we chose 3 centimeter pieces.
Yes. And x is number 7 centimeter pieces.
So then you subtracted them both by the. Oh. Okay. I mean, I've done like the elimination problems. It's just worded kind of weird.
This one's tough. Yeah. Really tough. Okay. Do you want us to do any of 13, 14, or 15, or go on to 16, 17? What would be best? We got limited time here, maybe 1 or 2 more questions. We'll see.
We can just do 13 or 14 then.
Okay. So 13 says, you must graph, thou shalt graph.
Using graphing.
Yeah, you have to graph. So I would solve it for y in both of these. So to do that, let's look at that first one there. 2x minus y equals 3. Subtract 2x, subtract 2x. You have minus y equals minus 2x plus 3. And then you're going to divide by -1. So y equals 2x minus 3. The reason you want to solve for y is it just makes graphing a lot easier, because you've got the slope and the b value now. So the b value is -3. And the slope is really 2/1. So from that b value, you go up to right 1. So up to right 1 each time, up to right 1. And you get some points there. We're going to take the second equation here and solve for y. 3x plus y equals 2. Subtract 3x from both sides. Y equals -3x plus 2.
So they're not going to be parallel.
They're definitely not parallel. They got different slopes. So starting at 2, b value of 2, you going down 3, right 1, down 1, 2, 3, right 1. You can see that they intersect there at that point. 1, -1.
Yeah.
Any questions on that?
No, just give me a second to graph it.
Sure. You can always solve it another way and then just verify that your answer is correct with the graph, especially if you're not sure if your graph is right. Like this one would be good to use elimination to find the answers and then use the graph to show that it's the same.
Yeah. All right, I'm good with that one.
Okay, 14. All right, use elimination. You want to eliminate the variable that's opposite in sign, if at all possible, or the same coefficient. So see on the 7y's have the same coefficient. We want one of them to now be negative. We really want like negative 7y to add to positive 7y. So in this case, you multiply by -1 everything. So that becomes minus 5x minus 7y equals minus 41.
Okay.
So now you're adding 3x minus 5x, that's minus 2x. The 7y minus 7y cancels, equals 6. All right, so what does this become? What is the value of x?
-3.
-3, good. Unfortunately, there's not a good equation to go back to. They're both equally bad. So you just pick one. Let's just pick the top one. 5 times x plus 7y equals 41. 5 times -3 plus 7y equals 41. -15 plus 7y equals 41. Add 15 to both sides. 7y equals 56. Divide by 7 and y equals 8. Maybe the second equation was slightly better. I mean, really
Yeah, but
about the same, about the same. So if you have time on the test, you should check your answer in the other equation. Like you should try those values in the second one, see if they work. They should.
And then like the solution you would write it as
X comma y or x
Eight.
equals.
Yeah.
You want to maybe write as an ordered pair or write x equals -3, y equals 8. However your teacher's been doing it in class, you know, mimic them. They're the ones grading you.
Yeah.
For that.
So yeah, I feel pretty better about the test.
Good. That's great. Yeah, we'll go ahead and stop here. Like I said, if you need, we're scheduled to meet on Wednesday.